Hey guys, Mrs. Young here. We're going to go ahead and go over a document and part of a lesson that we did in class today. I want you to have exposure to what it was that we talked about in class, even though you were unable to be with us today. So work through this with me. Go ahead and get this copy put into Notability and into MOS so that you can interact with it and write all over it like me. Okay? Ready to get started? Let's go. The scientific method is a process that scientists use to better understand the world around them. So we're going to go ahead and highlight that. It includes making observations and asking questions, forming a hypothesis, designing an experiment, collecting and analyzing data, and drawing a conclusion. This is sometimes also referred to as scientific inquiry. A hypothesis is a possible explanation for an observation. A good scientist will design a controlled experiment to test their hypothesis. Now remember that first stems from having a testable question, one that you can design an experiment for rather than just one based on opinion, like which pizza topping is best. In a controlled experiment, only one variable is tested at a time. It is called the manipulated or independent variable. The experimental group will test the independent variable. Okay, so we're going to end up with two different groups here. We're going to see that we're going to have an experimental group and a control group. So let's go on to read about the control group. The control group will be left alone, so you have something to compare your results to. The variable that determines the data is the responding or the dependent variable. It responds to the manipulated variable. So we're going to stop here for a second. I'm going to want you to write a few little notes here. So let's take this up here, and we're going to write that the independent variable is the one that you purposely change. And if we are graphing this, this is going to go on the x-axis. And when we have our other variable, our dependent variable, let's come down here with this one. This is the one that you measure. And if we were to graph our results, it would be on the y-axis. Okay? So the dependent variable responds to the manipulated variable. All other variables in the experiment must stay the same. Has to stay the same, because if you change more than one variable, you will not know which variable explained your results. Once something has been tested many times by many different scientists, it becomes a scientific theory. So tested many times, many different scientists, it becomes a theory. That is different, however, than a scientific law. A scientific law describes what will happen every time under a particular set of conditions. So we're going to come over here and we're going to say explains something in nature. So what comes to mind for me right away is the law of gravity, that we don't have to explain write up our conclusion, the effect of gravity, because that's a law that's going to happen every single time. So it's going to explain something in nature, and when we come across it in an experiment, we don't have to explain why that happens. We just know that it does, okay? All right. If the answer is true, write true on the line. If the answer is false, replace the underlined word or phrase with one that makes the sentence correct. So forming a hypothesis is the first step of the scientific method. Well, I could come right back up here and I could see that making an observation is going to be the first step in the scientific method. So I'm going to go ahead and write that in here. So, making an observation. Followed very, very closely, right, with asking a question. But you have to observe something before you can ask a question about it, right? So making an observation is the first step in the scientific method. A scientific law is different from a scientific theory because it describes something in nature without attempting to explain it. Yep, that's true. In order for a hypothesis to be testable, scientists need to be able to carry out investigations that will either support or disprove it. Yes, that's true. It's got to be something that we could design an experiment for, to say if this supports your hypothesis or does it not support your hypothesis. The experimental group is the group that is left alone during the experiment. That is false. So the one that is left alone during the experiment, that would be the control group. The manipulated variable is the same as the independent variable. So I could come back up to my text and I could see, yep, the manipulated variable is the same as the independent variable. So that is true. All right. So make sure that you have all of this filled out so far. And let's go ahead and scroll up to the next part. So this next section is going to be matching. So for me, it's easier for me to go from the right side and then put the correct letter in the left side. Okay, so but whatever strategy works for you, okay? This group shows the effect of the variables being tested. So it's the one that is receiving the experiment. So that is going to be your experimental group. This is the one variable that is changed. The one that is purposely changed is our independent variable. A well-tested explanation for experimental results, well-tested over and over and over again, is a scientific theory. The many ways in which scientists study the natural world. That is scientific inquiry, scientific method. A possible answer to a scientific question. Possible answer. That is going to be a hypothesis. This describes an observed pattern in nature. That's scientific law. This group is left alone and not experimented on. So that is going to be your control group. That's the one that you are going to compare everything to. This is the variable that gets measured. That is your dependent variable. So how are you going to measure it? All right. So make sure that you get all of your vocab words for this particular reading updated. Okay? All right. Now we're going to apply that to a few scenarios here. A company wants to test a new dog food that is supposed to help overweight dogs lose weight. 50 dogs are chosen to get the new food, and 50 more continue with their normal diet. So altogether, we have 100 dogs in this study. We have the experimental group that's going to get the new dog food, and we have our control group that's still staying on their regular diet, okay? So after 1 month, the dogs are checked to see if they lost any weight. All right, so we're going to identify the independent variable, the one thing that we are purposely changing, and that is the type of food. So one group is going to receive, the experimental group is going to get the new dog food. And the control group is going to stay on their normal diet, whatever that was. Okay. So then let's come in and look at what it is that we're going to measure. We're going to check to see if they lost any weight. So what is the thing that they are measuring? They are measuring weight loss. Okay. Alrighty, let's take a look at this next one. A new sunscreen has been developed that is supposed to be more effective at preventing sunburn. 30 participants spray one arm with the new formula and spray the other arm with the leading formula. After 4 hours in the sun, their skin is evaluated for any redness. So what is the one thing that we are purposely changing between the two groups would be the type of sunscreen. Okay? So the experimental group, so really what's interesting about this little scenario is that we've got the same people. We've got 30 people, and we have the experimental group is going to spray one arm with the new formula. So let's go ahead and have that as our experimental group. So it would be the arm with the new formula. Okay. And then we have got our control group, same group of people, and they're going to spray their other arm with the leading formula. Okay. So it's going to be other arm with the leading formula. Whatever that is, we don't know what that is. Okay. So if we can envision this, we've got 30 people. We're going to spray one arm with the new formula that is supposed to be helping against getting sunburnt, and we're going to spray our other arm with a leading formula, and we're going to figure out which one prevents sunburn. So what is it that we are going to be measuring? We are going to be measuring our skin redness. Okay, so we're going to be measuring redness. So which one does a better job? They're going to take a look at both of those arms. They're going to compare it. Our control here is that we have the same people exposed to the same sun at the exact same time, okay? And they're just going to see which one does a better job at preventing sunburn, okay? Let's take a look at this final scenario. A student wants to study the effect of sunlight on plant growth. In his experiment, 12 plants receive normal amount of sunlight, but half of them are kept under bright sun lamps all night long. After 6 weeks, the plant heights are measured. All right, so what is the one thing that they are purposely changing between the two sets of plants would be the amount, let's abbreviate that, of sunlight. That's what they're purposely changing, okay? So we have our experimental group that is going to also have sun lamp at night, okay? Because they set it up by saying that 12 plants receive normal amount of sunlight. So both of them are going to receive the normal amount of sunlight. So that actually is what the control group, just normal sunlight. I know this is a little messy, sorry guys. They're going to receive the normal sunlight. But then we have this other group who is also going to receive the sun lamp at night. All right, so that is the experimental group is also going to receive the sun lamp at night, in addition to having the sunlight during the day like the other group. Okay, so what is it that they are going to measure? Let's change that to green. They're going to measure the plant's height. Okay. Plant height. So do the plants do better Do they grow taller when they are also exposed to additional light at night through the sun lamp? That's the experiment. So the control, what we have to have the same type of plant. We have to have the same plant size right from the beginning. They've got to be the same height right from the beginning. So same plant, same height, same sunlight, same soil, same fertilizer, same size pot, same amount of water. All of that has got to be the same. The only thing that is different is the addition of the sun lamp at night for the experimental group, okay? And after 6 weeks, they're going to measure the height of both plants, both groups, and see, does this sun lamp make a difference, okay? Alrighty, so make sure that you file this away in MOS and go on and watch or do any additional activities that we had on the in-person day. All right, take care now. Bye-bye.